than each other. The first one just says rewrite as an exponential function. In that case, I just need to get rid of the logarithm. So on my left-hand side, I need to raise that to an exponent base 2. So we have log base 2 of x. And the whole point of that is my exponent and my log going to cancel out. But what I do to one side, I have to do the other side. So we have 2 to the y. And this one's actually going to be 2 to the y equals x.
Sorry, I was talking to a teacher.
I so don't care. No, I'm just kidding. I'm glad you're back. I'm glad you're here. All right, finding the inverse. Here is where the slight difference happens. Finding the inverse tells me I need to switch my x and y values and solve for my y. So when I switch my x and y values, we would change this to being x equals log base 2 of y. Now I do the same thing because I need to solve for y, so I want to solve for that guy right there.
Oh, so then you do 2 to the x equals
yes.
y.
We'll have 2 to the x equals y. Same idea, right? It's just asked in a slightly different way. This one is just change it to an exponent. That's all you had to do. This one was find the inverse. So you had to flip and solve.
Wasn't the quiz originally like tomorrow?
Was it?
Yeah, I always felt like it was tomorrow.
I always thought it was Wednesday.
Wait, why do you have a pharmacy school thing?
I think that's him saying that he's getting over being sick.
My wife is in the pharmacy program at MCW.
What does
that
that stand for? Milwaukee
one?
Medical College.
That's probably right.
It was MC. Wait, is it MCM?
This is MCW.
Oh, I thought it was MCM.
And then this is the chemical thing of caffeine.
Awesome.
That's fun.
But like, what if you put something else in?
Next year.
Not as good as.
Oh, better one. All right. We are going to do log base a of square root of 20. And what are we doing? We're trying to rewrite each expression in terms of log base a of 2 and log base a of 5. Oh, that really leaned up there. All right. Let's first rewrite it so I don't have the square root. So we're going to say that equals log of 20 to the 1/2. So I'm going to do 20 to the 1/2. Now I'm thinking about how I can rewrite 20 with 5s and 2s. Well, I can write 20 as 5 times 4. So that's my 5. Now I have to think about how I rewrite 4. Well, I can rewrite 4 as 2 squared. So I can rewrite 20. So this whole thing I'm going to rewrite as log base A, maybe I'll use brackets, of 5 times 2 squared, and that's all going to be raised to the 1/2. Because 5 times 2 squared equals 20. Now what I'm going to do is I'm going to, in effect, I'm distributing this 1/2 to both of these. Which will give me equals log base A of, well, we have two things now, so we're going to have 5 to the 1/2 times 2 to the 1/2 times 2 is just to the first. Well, now we're going to use the product property. The product property says if I'm multiplying 2 arguments, we can change it to addition. So we're going to turn this into, don't hate me, but I'm going to do 2 steps in one. I'm going to bring that 1/2 out front of it. So I have log base A of 5 plus log base A of 2. And that's the long and short of it. Any questions on any of those steps? Good? Nick?
I've always just like wondered, is the 2 an or like would the 5 and the 2 be exponents to the A?
No.
They're just the next number.
They're the log base A of whatever you have. That's how you say it.
Okay.
So don't call them exponents of A.
Yeah.
And in fact, it wouldn't be exponents because remember how logs work? This would be A of whatever's over here equals what's inside. Is that log roll thing? Other questions? Kate, was that your question?
Mm-hmm.
Oh, that's weird. Convenient. Okay, if there's no other questions, today's lesson is going to go pretty quick. You should almost pretty much get done with your homework
Oh my gosh, I hope.
in class. Well, this homework, I'm going to assign 2 homeworks tonight. No, I'm just kidding.
Scared me.
Wow, thanks.
These are all properties we've done so far. I put a couple additional ones down that we didn't really put down, like log base a of a equals 1. Well, that's just saying a to the first power equals 1. In other words, these just cancel each other out, because this would be, kind of think of this as being log base a of a to the first power. Logs cancel out exponents, I'm just left with 1. Log base a to the first power equals 0, because that is a to the 0th power equals 1, if you do that kind of log rule thing. The rest are ones that we put down before. So these are all the different properties you can use. A lot of them you can just kind of discover by solving problems. All right, the first thing we're going to do is we're going to use rational approximation for a logarithm. So we're going to use our calculators to actually solve this. Now bear with me now. I'm going to do this wrong. It's not wrong. You can absolutely use this method, but I don't want you to write it down here because there's an easier method to solve these. So the first method, so we're not writing this one down. We're just watching. Well, if I needed to get rid of that 1.03 to get that x alone, what I would do is I would take the log of 1.03 of both sides. So that'd be log of 1.03 to the x equals log of 1.03 to the 5. Well, these logs and exponents would cancel out, and I'd be left with x equals log of 1.03 to the 5th, which is all good, except you don't have a button to do this on most of your calculators. You don't have a base of 1.03. You have a dedicated log to the 10th button. So if you got to here, you could change your base, which we're going to learn about in just a second. And then you could plug in your calculator. We're going to do something slightly different. So I'm going to pretend I have a scientific calculator, and I don't know how to change base. I only have a log button. So we're going to use the properties of logarithms to actually solve this into something that I can just use the log button for. Yes, this will be the correct method that I want you to see. So I'm going to take the log base 10 of both sides. And if you're like, why? We'll find out in just a second. Now, the thing about taking log base 10, these don't cancel out. They have to be the same base to cancel out. So nothing cancels out, nothing's the inverse. This is log base 10 of 1.03. If they're the same base, they'd cancel out. They are not, so they won't cancel out. So instead, I'm going to take this itty-bitty x and throw it outside, because I can use my power property. I'm just going to carry it outside to get me x times log. Remember, there's a multiplication there of 1.03 equals log of 5. Well, because this is x times a number, I can just use division to move this over here. So I'm just going to divide both sides by log of 1.03. That would cancel out that. Divide by log of 1.03. And we will have x equals log of 5 all over log of 1.03. Now, any scientific calculator or graphing calculator has just a dedicated log button. So now we just got to do log of 5 in our calculator. Divide that by log of 1.03. And if you have a calculator, go ahead and do that. But you should get out about 54 point, I did say, did I put round to anything? Round to the nearest hundredth. So we're going to have 54.45. It sure is. I'm going to do something different with the next one. It's very, very similar, but slightly different. It is because if you look at your graphing calculators, you have a dedicated log base 10 button. What's the other dedicated button you have for logs? Yeah. We have the natural log, which is log base E. So sometimes, rather than having to write log over and over and over, sometimes it's nice to just write ln. Because ln has the exact same rules as log does, because it is log base e. So we're going to do this exact same stuff, but this time we're going to use the natural log.
Will you get the same answer?
You will get the same answer.
Wow.
So I'm going to do the natural log of 5.44 to the x equals the natural log of 2.3. We're going to divide both sides. Oh, no, I got to bring that x out first. You're outside now. ln of 5.44 equals ln of 2.3. Divide both sides by ln of 5.44, so we have x equals ln of 2.3 all over ln natural log of 5.44. Plug that in and tell me what you get out. And for those of you with calculators, plug it in with logs instead of ln. So pretend like you did logs on both sides, which would be log of 2.3 over log of 5.44. See what answer you get to that. The same exact answer. Yep, it is creating a ratio between the two. So the ratio, no matter the base, is going to be preserved. And that leads us to our next section, which is changing the base. Since ln of 2.3 over ln of 5.44 is the same thing as log of 2.3 all over log of 5.44, that means we can change bases. If we get the same answer out, changing those bases, we can use that to actually come up with a formula. And our formula for change base, which mine looks a little weird down here, is if I'm given log base b of x, and I can't plug that in my calculator, all I'm going to do is I'm going to take that x and I'm going to throw it up here, a log on top of a fraction and a log on the bottom of a fraction. Now I can pick any value I want for a. You're more likely going to pick 10 or e, so you can write ln. Those are going to be basically your two choices. Either do log base 10, because it's in your calculator, or change it to log base e, which is also in your calculator. I don't know why. Yours are lined up better than mine, right? Yeah. Okay. So log base 2 of 6. I can't plug that in my calculator. But if I took that 6 and threw it up there, took that 2 and threw it down here, and changed my a's to 10s, now I have two numbers I can plug in my calculator. So following this, we come up with 2.585. So log base 2 of 6 equals 2.585. In fact, plug in your calculator 2 to the 2.585. Plug in your calculator 2 to the 2.585. What does it come out to? 6.00. Yeah, about 6. So that works. Because this is saying 2 to what power equals 6. So I can even check it. It works. Change base. Just take your base, put it on the bottom. I think it's kind of easy to remember. Base goes on bottom. Your argument goes on top, and then just pick whatever numbers you want here. So, in fact, you could do ln of 6 divided by ln of 2, and you come up with the exact same answer.
You can do it wrong, kind of, and still get the right answer.
You can't do it wrong and get the right answer. I don't know what you mean.
You can do it. You can flip them and get the same answer. Wait, you said you could do ln.
Yeah.
6.
Yep. Over ln of 2.
Did you say ln 2 over ln?
No. You can't flip that. No. You come with the wrong answer.
Okay, yeah.
Yeah, Luke.
You told us to do 2 to the 2.585. Wouldn't we know that would come out to 6 because that literally just means 2 to what power is 6?
Yeah.
Okay.
I'm just showing you that it's right.
Oh, okay.
That I'm not just blowing smoke.
Okay. My cousin doesn't know.
I didn't just make something up that just works. All right. Let's go put this in practice. So our first one is log of 81 to the 27th. I have my calculator out. Awesome. but my calculator doesn't have a log base 81 button. So what we're going to do is we're going to convert it to a log base 10. So I'm going to rewrite this as log base 10, which means I don't have to put anything down. So we're going to do the log of our argument, 27, over the log of our base, which is 81. And that should come out to about, and correct me if I'm wrong, because you should be doing this along with me, 0.75, or I'm just going to put 3 over 4. So it's exactly 3 over 4. I can put an equal sign. Or you can put 0.75.
Does it make you excited when you can use an equal sign and not like the squiggle?
Yes. I should have known it was equal, because those are powers of each other. All right, log base 5 of 36. Let's use ln this time. Let's say I know I have a natural log button on my calculator, so I can do ln of 36 divided by ln of 5. And that should come out to 2.23. In fact, if you do log of 36 divided by log of 5, it comes out as 2.23. So it really doesn't matter what base you pick up here as long as you make it the same base on the top and the bottom. Last one's kind of uninteresting because we've done enough of these. D is going to be slightly different. D is going to be slightly different. So we can change base. It just creates kind of a kerfuffle of problems. So we're going to do log of 18 over log of 4, and this one should come out to about 2.08. All right, our next one. So you could use our change of base thing. I could say the log of 12.33 over log of x equals 2.3. Multiply stuff, slowly solve our way down there. It will work. I'm going to pick an easier way to do it. An easier way to do it is to, well, if this was a 3 and I wanted to get rid of that log, I would just raise everything to an exponent of base 3. Well, this has a log base x. So let's raise everything to an exponent with base x. So I have log base x of 12.33 is going to equal x to the 2.3. Well, the whole point of doing this is log base x is going to cancel out with exponent base x. And now I have 12.33 equals x to the 2.3. How do I get rid of something if it's x squared? Yeah.
All right, do you say x squared?
Oh, I don't care. Either one.
Okay, well, we have like a math button that, we have a math button that has like, where you have like the x and the x you can put in the values.
For the root?
Yes.
You're talking about root?
Yes.
Yeah, so we could, and if your calculator has this button, you can just take the root 2.3 and plug it in. I'm going to say I have a scientific calculator that doesn't let me do that. So let's just say I have a scientific calculator that doesn't let me put roots in that are 2.3. Well, in that case, all you need to do is raise this to the 1 over 2.3 power, which is the same thing as taking the 2.3 root of it. A fraction in our exponent means I'm taking a root. In other words, 2.3 times 1 over 2.3 just equals 1. So I'll have x to the first. Well, what I do to one side, I have to do to the other side. So we raise this to the 1 over 2.3. And so, in effect, the only thing I have to plug in my calculator is 12.33 and raise it to the 1 over 2.3, which is sometimes nice, rather than having to go that math button route and putting stuff in correctly. Sometimes it's just nice to be able to just type in 12.33, raise it to the 1 over 2.3. Make sure you put 1 over 2.3 in parentheses. And you should come out with about 2.98.